Picot normal form. Now, Picot normal form says that first thing, your table should, or your relation should be in first normal form, second normal form, and third normal form. Apart from that, all the determinant should be the candidate key. So if there is a relation, so in the functional dependency, if we have this functional dependency, let's say A determines B, B determines CD. So in this, if A closure is A, B, C, D, it means that A is the candidate key. So in the functional dependency, all the determinant part, means left hand side part, should be the key, should be the candidate key. Now in this case, this satisfies BCNF. If you can see, this satisfies BCNF because left hand side part is the candidate key. But in this, BCNF has not been satisfied. Why? Because the determinant is not the candidate key. Determinant is a non-key, right? So we have to check for that. It is very simple that the BCNF is very simple. It is like some complications are there in third normal form, but the BCNF is very much simple. Let's take one example and try to solve it. Let's say we have a relation X, Y, and Z. And we have functional dependency, which is X, Y determine Z, Z determines Y. We have to solve up to BCNF, Picot normal form. So the solution, the first step of the solution is to find candidate key. So we have these two functional dependencies. We'll start with this XY closure. We are getting X and Y as well as Z, which is equal to R. So we consider candidate key as XY. Do we have Z closure is also a candidate key? Let's see. It is not a candidate key. So the candidate key is XY. Now the second step is to check for second normal form. Now, while checking for second normal form, in the functional dependency set, we have to see for any partial functional dependency. X, Y determines Z. Do we have any partial functional dependency? X, Y, we are getting it. So it is satisfying the second normal form. This is one functional dependency. Second functional dependency is Z determines Y. Z is the part of the key? No. So it is also in second normal form. Next is, do we getting the transitive functional dependency? So we'll check for third normal form. So what we have, if we have X, Y determines Z, which is the first one, and Z determines Y. So we'll apply the transitivity rule. So with transitivity rule, we can find X, Y determine Y. This is the key, no doubt, but this is not the non-key. It is also a, what we can say, prime attribute. So for third NF, violation of the third NF is key is determining some non-prime attribute, but it is determining the prime attribute. So there is no harm on it. There is no harm on it. So it is also satisfying the third normal form. Do you understand this? We are getting the transitive functional dependency. This is your transitive function dependency, but this transitive function dependency are not satisfying the condition which is violating the third F, which just says that any non-prime attribute is determined by the candidate key. So here it is not the non-prime, it is the prime attribute. XY is the prime attribute because XY is the candidate key. Now check for Picot normal form. In the Picot normal form, what it says, every determinant part should be the candidate key. So X, Y determines Z. Is this satisfy the BCNF?
Yes, sir.
Because the determinant is the candidate key? Yes. Now the second functional dependency, which is your Z determine Y. Z should be the candidate key, but Z is not the candidate key. Here we have XY is the candidate key. So it does not satisfy the BCNF. So what we have to do? We have to split. So the table with X, Y, and Z, because this is not satisfying the criteria, so Z and Y will be in one table, and in R1, we cannot put X, Y, and Z in one table, right? It will be the same. We'll take XY is in one table because XY is the candidate key. So XY in one table, and ZY, because of that we are having the problem. So ZY will be in one table. Now, if we talk about R1, it is made with candidate key. So it is in BCNF. And ZY, which is now is in BCNF. Why? Because in R2, what is a candidate key?
Z.
Yeah, so Z closure will be Z and Y, which is equal to R2. Then Z will be the candidate key, and now Z is determining Y. This is nothing but Z is the candidate key, so it is in BCNF. Right. So this is the answer.